Morning girls, we are in continuation of our chapter number 13, the electric current and its effect. So today we will study about the electric fuse. What is an electric fuse? Electric fuse is a safety device which is made up of the material with low melting point. Generally it is made up of the alloy of tin and lead. That means a mixture of tin and lead. Okay, so I'll tell you an example. We have a bulb in our house. Okay, when sometimes what happens when the excess current comes, so our bulb, it gets damaged, the filament gets broken, and we say that the bulb has got fused. Now it cannot glow again, right? So the excess amount of current has fused the bulb, right? Now this excess amount of current, it can damage our other appliances also. We have refrigerator working on electricity, we have TV working on electricity, we have various other things, we have a electric motor working on electricity, and so on. What happens if the excess amount of current comes, then these appliances may get damaged. In order to save these appliances, we have electric fuse attached to our main circuit, right? So this electric fuse is the safety device which is made up of the material with the low melting point. It helps in saving the electrical appliances from the excess amount of current. How does it work? See, the electric fuse is made up of a plastic covering is there, or sometimes we have a glass covering, and it has a thin wire inside it. This thin wire is made up of the material with a low melting point. It is made up of the alloy of tin and lead. So what happens when the excess of current comes? Then what happens? This wire, it melts and it breaks down. As a result, what happens? The whole circuit gets broken. Okay, so what happens when the circuit gets broken? Then the electric current cannot flow through it. So electric current will stop. So with the stop of the electric current, our electrical appliances will get saved, right? This is how this fuse works. Now after this we come to the magnetic effect of the current. What is magnetic? Up till now we have done till what effect of current we have done? The heating effect of the current. When the electric current passes through any material, then it produces heat, like the iron we have at home or the geyser we have at home. All these, they are producing the heat. Okay, next effect we are studying about is the magnetic effect of the current. What happens when the electric current passes through any appliance or any conductor? When it passes through that, it also produces the magnetic field around it. Magnetic field is also produced around it. Okay, and this magnetic field we can use in the various purposes. How? I'll tell you afterwards. First, we will discuss about the solenoid. Before that, we will do this activity number 1. This is the activity number 1. Aim is to understand the heating. This we have already done, the heating effect. This is the activity number 2. It is to show that an electric current passing through a conductor produces the magnetic effect. What you will do? You will take a dry cell, an insulated copper wire, a wire is there, a switch, and a small magnetic compass. Okay. Here we are not taking the bulb, we are taking the magnetic compass. Keep the magnetic compass on the table and place the insulated copper wire next to it. We have attached this wire to this compass. Connect the ends of the wire across a cell through the switch. We have attached to the cell one end, and the other end also we have attached to the other part of the cell, another terminal of the cell, and we have attached the switch also to it. Now, note the position of the needle in the compass. First, you will see the position of the compass, the needle. Okay. Turn on the switch and observe what happens to the needle. After that, what will happen when you switch it on? The circuit gets completed, the circuit gets closed, and the electric current starts flowing. What will happen to the needle? You will see that. Observation. When a magnetic needle is placed near the current carrying conductor, the magnetic needle shows deflection. That means what will happen? This needle will start moving. It will start moving because the magnetic field has developed around this magnetic compass. So what is the conclusion? A current flowing through a conductor produces a magnetic effect. It produces a heating effect also, and it produces a magnetic effect also. Okay, and this is called the magnetic effect of the current. Now we come to the solenoid. What is a solenoid? Solenoid, it is a cylindrical shaped coil. It is a coil which is wounded and it is made into a cylindrical shape. Okay. Now what happens is, when the electric current is passed through this coil starts behaving like a magnet, like a bar magnet. Why? Because the electric current, it produces a magnetic effect. Okay. So, and this wire is called solenoid. When current passes through it, it acts as a magnet. Now, the strength of the magnetic field which is developed around it, it depends upon the two things. First is amount of the current. More amount of current is flowing through it, more will be the magnetic field. And B is the number of turns of the wire. More the number of turns are there, more magnetic field will be developed. Is that clear? So this is important to learn. The strength of the magnetic field, it depends upon two things: amount of the current passing through it and the number of turns of the wire. So let's do this activity number 3. It says that aim is to show that the strength of the magnetic field of a solenoid depends on the current flowing through it and the number of turns of the coil. Both things we will prove it here. Material required: dry cells, insulated copper wire, switch, small magnetic compass, and 2 small pipes of length about 5 cm and diameter 2 cm. Okay, so here what we have done, we have taken this wire here. Wind the insulated copper wire on the small pipe and make a solenoid of 10 turns. So what we have done, we have wounded that copper wire on this pipe, okay, about 10 turns. Then on the other one, what we will do, we will take 2 such pipes, okay. On the other one, we will wound it and we will make 20 turns. So there will be 2 apparatus here. One solenoid with a 10 turns, one solenoid with a 20 turns. Now case 1, first case is this. Place a magnetic compass near any one of the solenoid. We will place it here only. Connect the solenoid into a single cell. We will connect it. Switch on the circuit and notice the deflection deflection of the needle in the compass. Now connect the 2 cells to the solenoid and observe the deflection of the needle in the compass. What is the change in the deflection that you observe? So what we have done here, it is having 10 wounds here, 10 turns. First we will connect it with 1 cell and we will see what is the deflection, how this needle is moving. Then we will attach the 2 cells and then again we will observe our reading. In the second case, what we will do, place the magnetic compass near the solenoid, okay, and then notice the deflection to the magnetic needle of the compass. Repeat the same using the other solenoid of 20 turns. So that means in first case what we are doing, in first case we are taking only 1 solenoid, let us say of 20 turns or 10 turns, up to you. Here we are checking on the amount of the strength. What effect the amount of the strength makes on the magnetic field. So in first thing what we will do, we will attach 1 cell and second after some time we will attach 2 cells on the same solenoid. Okay, we will observe the readings. In the second case what you will do, you can take any solenoid of 10 turns. You will take both the solenoids here. Okay. We will take both the solenoids, but the cell will be 1 or 2, whatever you want. Okay. So what you will do is, you will first attach the solenoid of the 10 turns and observe the reading. Then we will attach the solenoid of the 20 turns and then observe the reading. Okay. So observation. Deflection in the needle of the compass is more when the more cells are attached. So in the first case, when 1 cell was attached, the deflection was little bit, but when 2 cells were attached, the deflection or the movement of the needle was too much. So that means the magnetic field depends upon the amount of the current. In second case, what happens? The deflection in the needle of the compass is more when solenoid of more turns is used. So in the solenoid of 10 turns, the deflection was less, but with the solenoid of 20 turns, the deflection was more. Is that clear? So we have reached to the conclusion that the strength of the magnetic field of a solenoid depends upon the amount of the current and the number of turns. Is that clear? Now we come to the electromagnet. What is an electromagnet? Electromagnet is a device which acts as a magnet when current flows through its coil. But it consists of a magnetic material such as soft iron piece and a coil of insulated copper wire tightly wound around it. So this is the difference between solenoid and electromagnet. What is there in electromagnet? There is a soft iron piece here in the center, and around that the copper wire is wounded. And what was happening in the solenoid? In solenoid we did not have any iron piece in the center. It was just the copper wire wounded. So this is the difference between solenoid and electromagnet. Though both of them will develop the magnetic field when the electric current will pass through them. Right? Now, the material on which the insulated wire is wound is called its core. So this iron piece is called core. Okay. It is a temporary magnet. That means it loses its magnetic properties when the current through the electric current circuit is withdrawn. When we are passing the current through it, we will have the magnetic field. As soon as we withdraw the current, we stop the current, the magnetic field will also go. Okay. Now let's do this activity number 4. To construct a simple electromagnet and to show that it is a temporary magnet. How to construct a simple electromagnet? How will we do that? Material required: 1 iron nail, insulated copper wire, switch, ball pins and dry cell. Okay. So wind the insulated copper wire on the iron nail from one end to the other. So we have wounded this copper wire on this iron. So this iron nail has become the core. It is the iron inside it. It has become the core, and we have copper wire around it. Remove the insulation at the free ends of the copper wire. Connect the ends of the wire across the terminals of the cell. Now what we have done, we have connected one end of the wire to the cell, and the other one we have attached switch to it and also taken to the other terminal of the cell. Bring one end of the iron nail near the ball pins kept on the table. So what we will do is we will put some iron nails here. We will put some ball pins near the iron nail. Now turn on the switch. Then observe what happens, and then turn off the switch and see what happens to the ball pins again. Okay. Observation. Ball pins stick to the iron nail when the cell is connected to the coil. And this is a switch, or you can do one thing. You can turn on the switch. When we turn on the switch, the current will flow through it, and this will become an electromagnet. Okay. So those ball pins, they will get attached to this iron nail. But when we switch off this, then the current will stop, and so the pins will get detached. They will go back to its places because there will be no magnetic field. So that means it is behaving like a temporary magnet only. When the current passes through it, it behaves like a magnet. Otherwise, it doesn't. So conclusion is, electromagnet acts as a magnet as long as the current flows through it. It loses its magnetic property when the current through the circuit is withdrawn. Okay. So this we have done. Now the applications of electromagnet and the electric bell, we will do it in the next session.